In the last video, we talked about divergence and saw its algebraic definition, at least, so let's kind of put it to the test. So we want to compute the divergence of the following vector fields. I'm going to tell you, pause the video and try it yourself. Okay, well, if we did this, I think the divergence here should be just 2, and so again, to do this, what we would end up doing is we would do the partial of, well, really x plus the partial of y with respect to each of those variables. So d dx of x and d dy of y, and as we know from Calc 1, that's 1 plus 1, or 2. Okay, and similarly here, when we look at the divergence, this should be -2. Okay, so now I'm just kind of curious what this looks like graphically. So if I pull up a vector field grapher, okay, I've plotted xy here, and I'm using the GeoGebra one that you can just Google. So if we kind of look at this, we notice that everything is going outward, and okay, so that's interesting. And so what happens if I zoom in on just a little region? I don't know, pick a region at your choice, but maybe I'm looking right around here, right? I'm noticing that, well, if I look in this tiny region, right, there's stuff flowing in and out, okay, but everything's going in the same direction. Okay, that's interesting. If I happen to look at the other vector field, and just change these all to minus sign, okay, again, now everything's flowing inward towards the origin, and so again, I look at that little region here, maybe, and I say, okay, well, stuff is flowing in to it, but looks like it's actually decreasing as it gets closer to the origin. That's interesting. Okay, so then we're still kind of curious about what the divergence actually measures, and I'm going to leave that as an open question right now because I don't want to spoil my fun later. And so now here I have this vector field. I want you to come up with a good guess about what the divergence might mean here, or what it might be. Okay, well, again, if we kind of picked up on the language that I was using before, right, I was saying, well, if I look at a small region, right, and look in that, what is happening in that region? Well, I know stuff is flowing in and stuff is flowing out, right, and okay, and then I know it's flowing in kind of quicker at the top, at least in this case, and then it's flowing slower through the bottom. That's interesting. Now what I'm going to tell you is that this vector field is f is equal to y comma 0. Okay, so then now with that extra bit of information, I think you can tell me, oh, Professor Bright, the divergence is just 0, right? Because you do partial of x, partial of y, okay, great. So you get 0. Does that make sense with your guess? And I think to really understand why it is 0, we will talk about that in the next video, okay? So know that the answer is coming, but just in the next video.